We're going to be talking about quadrilaterals today. So the first thing we need to talk about are different vocab words that are going to go along with this section. The first word that you're going to be hearing a lot is perpendicular. Perpendicular just means to intersect at a right angle or 90-degree angle. So that would mean it looks like the drawing over here. These two lines are intersecting at a right angle. And usually that's marked with that little square box right next to the angle to show that it's 90 degrees. Another word you're going to be hearing is bisector. So that just means that you're going to be cutting into two equal segments. So if you have this shape here, this quadrilateral, and you draw two sets of diagonal lines, so one from the opposite sides and the other from the opposite sides, these two lines are being cut in half by each other, so they're bisectors. One way you can remember that is that prefix bi. Think of a bicycle. Bicycles have two wheels that are the exact same size, so it can kind of help you remember, okay, if we cut this into two pieces, it's going to have two equal sections. Another word you're going to be hearing is congruent, and we did hear this in our last unit, but it just means two figures that are the exact same shape and size. And you'll be hearing it more about the opposite sides being congruent. So if you think about a rectangle, the two opposite sides in a rectangle are congruent. So the sides are congruent here and the top and bottom are congruent. We use these markings, these little tick marks, to show that, okay, these two sides on the left and right are the same because they each have one tick mark, whereas the top and the bottom are the same because they both have two tick marks. The last vocab word that we have here is parallel, and that's two lines that will never intersect. So if you have these two lines right here, and they're marked with these arrows, that's showing that those two lines are parallel to one another. If they had two arrows like this, where they each had two sets of these little arrows, then that would mean those lines are parallel. So if you had a shape where there was two different sets of parallel lines, that would be the difference, just like those tick marks being one or two. Now if you go on to the next page, we have the properties of different quadrilaterals that we're going to be studying. And just a reminder that quadrilateral is just a shape with four angles and four sides, and you can remember that with that prefix quad. That always tells us we're talking about four. So the first type of quadrilateral that we have are parallelograms. And parallelograms have opposite sides and angles that are congruent. Opposite sides will be parallel, and the diagonals bisect each other. So we already have a lot of these vocab words that we talked about up top. So just as a reminder, opposite sides and angles are congruent. So you might see these tick marks across from one another. That would mean the left and right side of this parallelogram measure the same distance. And then same with the top and bottom. They can be marked with two tick marks to show that the top and bottom will have the same measurement. We can also use a similar kind of method for the angles. So this angle could have one line, while the one right across from it, they're opposites. Those will have the same measurement. Just like these two here then would have the same measurement, and we could mark it with two lines. So we did see this in our similar figures unit, so this should look a little familiar. Now the other thing that we are talking about is that the opposite sides are parallel. So remember, parallel just uses those arrows, so we would say the top and bottom are parallel to one another, just like the sides here, the left and right side will also be parallel to one another. The top and bottom are marked with just one arrow because they're parallel to one another, while these sides are marked with two because they're only parallel to each other and not to the top and bottom. Now the last thing we have are the diagonals, and they're going to be bisecting one another, and we'll look at that on our next page to go explore all of the diagonals in all of our shapes. Now another kind of quadrilateral that we'll see are trapezoids. So trapezoids have exactly one pair of opposite sides that are parallel. And then those are called the bases. And then there's special type of trapezoids, which is what we have here. This kind of trapezoid is an isosceles trapezoid. I spelled that wrong, sorry. Isosceles. And isosceles trapezoid, you might have heard of an isosceles triangle before where it has two equal sides. So an isosceles trapezoid has diagonals that are congruent, which we'll talk about later, but it also has these opposite sides that are congruent, so we can mark them with those tick marks. We also talked about the bases being parallel, so the top will always be parallel to the bottom there. So that is our one set of parallel sides, whereas if you look at the sides on the left and right, eventually these two lines are going to end up intersecting. So there's only one set of parallel lines in a trapezoid. Now another type of shape that we'll have are rectangles, and that's this one on the left here. So rectangles have all the same properties that we talked about in a parallelogram. So it'll have all of those angles will be congruent, those opposite angles, but they're all actually 90 degrees or right angles. It's going to have opposite sides congruent, and it's going to have opposite sides that are parallel. So if you want to add all those markings to your shape, just as a reminder. And then specifically, rectangles will have all angles that are right angles, and then the diagonals will be bisectors. Moving over to our next shape, we have a rhombus. Another word for a rhombus could be a diamond, but this is the technical term that we'll be using for it. Opposite angles are going to be congruent here. So that would mean if this angle up in this top corner in the right will be congruent to the bottom left angle, and then these ones will also be congruent to one another. Now the opposite sides in a rhombus are congruent. And actually the special thing about a rhombus is that all sides are congruent. So we're actually going to change that to all. So all sides are congruent. So it's kind of like a square where all the sides are the same length, but their angles are not going to be right angles. It's just going to have opposite angles that are congruent. Now the opposite sides will also be parallel. So you can add in those tick marks there. And then finally, the special thing about the diagonals of a rhombus is that they are perpendicular bisectors. And we'll see a little bit more about that in our next page. Finally, we have a square, and a square will have all the properties of a rectangle. All the sides are congruent. The diagonals are congruent. And the diagonals are also perpendicular bisectors. So since it has all of the same properties of a rectangle, it will have opposite sides congruent, but all sides are going to be congruent to one another here. Opposite sides will be parallel, and then all the angle measures will be right angles. And then as we just saw, the diagonals will be perpendicular bisectors. So we'll see that on the next page. So there's all your properties, and you'll need to memorize these so that you can use them to help answer questions about which quadrilaterals have what in common and to find missing angles and side lengths. So now we're going to talk about what those diagonals mean. We just saw which shapes have what kind of diagonals, but now we're actually going to see what we're talking about. So in this first quadrilateral, this one has opposite sides that are congruent and opposite angles that are congruent. So this is a parallelogram. And in a parallelogram, the diagonals are going to bisect each other. So diagonals are just from one corner to its opposite corner. We draw a straight line. And we do the same thing with the other set of diagonals. And then that tells us that if they're bisecting, these two chunks of this line will be congruent, while these two sections of this line will be congruent. So they're bisecting one another. Now our next shape has opposite angles that are congruent and all sides that are congruent, so this will be a rhombus. And diagonals here are perpendicular bisectors, so it's a different type of bisector. So it's going to still have the two lines across from opposite angles. But the cool thing about these bisectors is that not only are they cutting each other in half like this, like we just saw in the parallelogram, but they're going to be intersecting at a right angle. So these two lines, when they cross, they're making a 90-degree angle here. And remember, we said perpendicular just means that two lines are intersecting at a 90-degree angle. So when the bisectors intersect at 90 degrees, they're perpendicular bisectors. Our next shape that we're looking at diagonals for is the rectangle. This is a rectangle because it has opposite sides that are parallel, opposite sides that are congruent, and all four angles are right angles. So the diagonals here are going to be congruent. So all of these pieces then will all be the same length. So they do bisect each other, but they're also all congruent. Our next shape we have is a square. And again, we're going to have diagonals that are congruent. So all the pieces will be the same, but they're also going to make perpendicular bisectors. So just like in our rhombus, we have perpendicular bisectors again. So you can kind of see that when those cross, they made that 90-degree angle intersection. This shape down here looks a little funky, but we have two sides in this shape that are parallel to one another. So you can see that these two left and right sides are parallel. None of the sides are congruent, but we have one set of parallel sides, so this is just a trapezoid. Diagonals are not congruent in a trapezoid. So if you try to draw them from their opposite sides, you're going to see that those two lines definitely aren't the same length, and these bottom pieces are not quite as long as their top half pieces, so they're not even bisectors either. So there's nothing special about the diagonals in a trapezoid. Now, the only kind of special trapezoid we have is an isosceles trapezoid. So notice we have our bases that are parallel here, but our two sides that are congruent. So this is called an isosceles trapezoid. And in these special types of trapezoids, the diagonals here, when you go ahead and draw them, actually I'm going to make them the same color, those are actually going to be congruent. So this whole blue line will be the same exact length as this whole blue line. Now, they're not bisecting each other because, as again, you can see these short pieces down at the bottom aren't quite as long as their top halves, but the whole blue line here is going to be congruent to the other diagonal. So we can say that the diagonals are congruent in an isosceles trapezoid. But if you have just a regular trapezoid here, not an isosceles, then the diagonals will not be congruent. So moving on to the next page, this chart is an always, sometimes, or never chart, and it's going to help you kind of remember the different things that these shapes have in common. So you read it by saying, well, if I want to go up, that's going to mean that statement is always true. If I go down, that means that statement can sometimes be true. When I go side to side, they're never going to be true. So the way that works is if you look at the first question, it says, is a rhombus a square? So I start at rhombus, and to get to square, I have to go down. So when I go down, that means sometimes. So we can say that a rhombus is sometimes a square, but the only time that a rhombus can be a square would be if its angles become those 90-degree angles. Squares and rhombuses have everything else in common besides those angles that are not always right angles. Now our next one says, is a square a parallelogram? So if we go from square to parallelogram, that would take us up. So up means we always have that. So a square will always be a parallelogram. That's because it has its opposite sides that are congruent, opposite sides that are parallel, and opposite angles that are congruent. It also has diagonals that are congruent and that are bisectors. Now we have the third one, is a rectangle a square? So to get from rectangle to square, we have to go down. So that's going to mean sometimes. Now again, a rectangle has its opposite sides congruent, opposite sides parallel, and 90-degree angles, and the only time it can be a square is if all the sides are congruent. If it just looks like a normal rectangle where one set of sides is longer than the other, then it won't be a square. But if you end up having a rectangle where all the sides are congruent, you can say that it's a square. So it's just a sometimes there. Now the last one we have is a parallelogram, a trapezoid. So to get from parallelogram to trapezoid on this chart, we have to go sideways. So whenever we have to go sideways, that's going to mean never. And that's because a parallelogram always has two sets of opposite sides that are parallel, whereas a trapezoid only has one set of opposite sides that are parallel. So those will never be the same. Now in our last section, we're going to be using all these properties that we've talked about today to answer some questions and find some missing angles and missing side lengths. So a fact that you're going to want to remember is that all the interior angles of a quadrilateral will always equal 360. So that means all those angle measures inside of a quadrilateral, the four of them added up will always have to equal 360 degrees. So in this first example, we have a rectangle where all the angles are 90. If you add 90 to itself 4 times, we get 360. Now, if you check this one, we have a parallelogram. So we would say 115 plus 65 plus 115 plus 65. If you check that in your calculator, all of those numbers add up to 360 degrees. In the last one, we have a trapezoid. So the two bottom angles here are both 90, and then we have 76 and 104. If we add up all 4 of those angles, we should get 360 degrees. So this fact is going to help us figure out what a missing angle would be in a quadrilateral if they give you 3 and you're trying to find the 4th angle. So to figure that out, you start with the total of 360, and then you subtract the ones that you know. So in this rhombus here, we have 360 minus 132 minus 48 minus the 132. When you subtract all of those, you get 48 as the remainder. So that means your missing angle there is 48 degrees. So in the next one, we have 360 minus 60 minus 120 minus 120. That's going to mean that last angle that's missing in this trapezoid is 60 degrees. You can try the last one on your own if you want before I answer it, but all you have to do is subtract all of the angles you know from 360, and this missing angle here is going to get us 360 minus 77 would be 183 minus 96 minus 52. So let's try that. 360 minus 77 minus 196 minus 52 equals 35. So that last missing angle is 35 degrees. Now, we also learned that the opposite angles of a parallelogram are equal, or they're congruent. So when you are only given one angle of a parallelogram, you'll know the opposite angle will always be the same measure. So in order to find all 4 angles, you'll need to subtract the known degree from 360 2 times, and then you can divide your answer by 2. So that'll be the measure of both the missing angles. So what we mean by that is if we have this parallelogram here and we see that these opposite angles are congruent, we know that we have 360, and if we subtract 117 from it, we'll get the remaining degrees in the rest of these 2 angles. So if we take 360 minus 117 minus 117, that gets us 126. So that means that these 2 angles need to add up to 126. Since it's a parallelogram, we know the opposite angles have to be congruent. We can just take 126 divided by 2, and then that can get us 63 degrees. So then that'll mean that these missing angles here are 63 degrees. So if you want to try the next one on your own, you may. We have 105 here, which means the opposite angle will have to be 105. So in order to figure out what's left over to split up, we have to subtract 105 from 360 2 times. So if we have 360 minus 105 minus 105, we get 150. So that means that these 2 angles need to add up to 150. Since they're a parallelogram, they'll be congruent, so we can divide 150 by 2, and that's going to mean that both of these missing angles here will be 75 degrees. Now finally, sometimes you'll have to find the missing side lengths of a quadrilateral. So in this first one, we have a rectangle given to us, and we have to find its missing sides. So rectangles, we know the opposite sides are congruent. So if this short side here is 8, this other side will also be 8. This side's 13, so the opposite side will be 13. And here we have an isosceles trapezoid, so we know that in an isosceles trapezoid, there are 2 sides that are congruent, and that would mean that this side has to be 9. Finally, we have a rhombus, and in a rhombus we know that all sides are congruent, which means every side of this rhombus would have to measure 11.2. So you'll have to memorize your properties of quadrilaterals and remember that all interior angles of a quadrilateral add up to 360 in order to be successful for this topic. Thanks for watching.